In this video, we're gonna give the final touches to our structure before the analysis, and for that we're going to cover many important features such as how to fix or establish the fixity at the ends of the bars, how to deactivate self-weight loads and surface loads automatically generated, how to move panels that carry surface loads, how to establish the deflection limits, the backplane and lateral backplane factors, and how to add additional load cases and loads. We're going to start by the fixity at the ends, and for that, continuing with the sequential order, we are going to move to properties menu. Here we find most of the features that we're going to comment in this video, such as pin and fix. The difference between the two tools is that fix is our more advanced tool, or we say more advanced because if we go to establish the fixity at the ends of, for example, this bar, we're going to have the control over which planes we are fixing or pinning, and up to what grade of pinning we're going to have. So 0 meaning pinned and 1 complete meaning completely fixed. We could establish a value in between 0 and 1 and establish them by plane. So of course, in the origin and in the end of the bar, we have control over which plane and in what type of fixity we want to have. The other tool, which is the one that we're going to actually use in this example, is the pin tool. In this case, pin makes the end that we pinned in every plane. So we do not get to choose in which plane, we just choose in which end. And it will be completely pinned, not a value in between 0 and 1, just completely pinned, meaning 0 fixity coefficient. So if we zoom in, we can see that if we click somewhere in the middle of the bar, the software automatically pins both ends. If I zoom in this other bar, for example, that we also have to pin, if instead of clicking in the middle of the bar, we click more towards one end, we will have control over which end we're pinning, but just that, not of what value nor what plane we're pinning. And in our case, all these 4 bars that are part of the beams to tag should be completely pinned. We're also going to pin the braces in the roof. So for that, we're going to move to the 2D view window that we created for the view, for the roof. And before we pin the bars, there's one thing we have to comment first. I have made a copy of the structure and I have it in a parallel window. By the way, this is possible in the software. If we have a CYPE-3D window already active, if we click again in the CYPE-3D access, it will open a parallel project and we can work in both at the same time. So let me speak about one tool that we skipped in the last video and that we could have used when introducing the braces. And that is the generate nodes at intersection points. So right now, the angle sections that we inserted for the braces are their length is from this node, in this case, to this one, so full bars. We, instead of inserting it without that activated, we're going to activate to see the difference. And when we go about inserting a bar with this tool activated, what we find is that whenever there's an intersection, the software automatically creates a node. So in this case, these bars are still, it detects them as an element, full element, but at least they have a node in the middle. We inserted them without this tool activated, so the way to fix it in our project is going to be by inserting a node in their intersection. So this is now something that we do have to do in our project is geometry, new node, and clicking in the midpoint of those bars. And to separate the bars into 4 pieces, we already used this tool. It's called Element. So we click in Element and we go about creating just individual bars until the intersection. Okay, this is how we wanted them to look, the braces, before we pinned them. And now we're going to pin them with the same tool that we used before. So it's pin ends here in properties menu. And by clicking in the middle of the bar, we make sure that the circles of the pinning come up, but both ends shall be pinned. And speaking of the braces in this structure are going to have a very specific function, and for them to work only for in tension, we are going to free them from their self-weight and the loads from the panel. First, let's free the braces from the automatic generation of self-weight loads. So in the load menu, we find these bars self-weight, and we click in deactivate and we choose all 8 bars that form the braces and confirm with a right click. We can tell that they are now freed from the self-weight because every other bar is sort of orange toned, and now our bars are completely gray. We can also deactivate the there's a panel that came from Portal Frame Generator carrying the weights of carrying the loads of the wind, and this panel distributes the loads in the direction that is now displayed on screen, horizontally in this case, and that affects our braces unless we do something about it. So the loads, we want them to be carried by these beams, but not our braces. So to free them from the surface load of the panel, we have this tool called Assign. And when we click here and select the 8 braces, and with a right click, we free them from the loads. There's double check that we can do, and that is by going to the analysis menu, clicking in issues, and there will come up an information symbol that says that the automatic generation of self-weight loads has been deactivated for these bars. Now, speaking about our panels, we're going to stretch the panel because we inserted, remember that we inserted in the frame a few bars that didn't come from Portal Frame Generator. We added them afterwards. So we're going to stretch the panel, and that is going to be done in the load menu, the panel options, and move. And the way to operate this tool is to select the panel with a click. Then it says select the vertices to move. So we select, for example, these 2 points, confirm with a right click, and then we have to select the point that is going to be taken as the reference of the displacement in this case this one, we move to select the next point, which is going to be our final destination, and we click on the right click on the mouse to confirm. And that way the panel now covers also those bars. Let's do the same thing. We click in the panel, we select the two vertices that we want to move. We'll confirm with a right click, and now we choose the point of reference and move it to the final destination. There's one important thing to comment about this possibility to stretch panels, and that is that if the variation, the editing that we do after coming to Site3D from Portal Frame is too big from Portal Frame, the loads, what the stretching does is it has stretched also the loads to cover let's make visible healing loads, visible load case, the wind load that the panel was carrying. So we now see that also these edges that we created are carrying the wind load. But if we had consulted the values of the load before we had done the stretching, we would have been able to see that the values have not changed at all. And that might not be completely correct. In this case, it's a very small difference. So, and the structure is very small, so it doesn't really matter these other values, but just pay attention please, because if the geometry it varies too much from the portal frame generator, maybe the wind loads generated won't be useful anymore. Okay, let's hide the issues by clicking analysis again and issues, so that disappears. And now that we have talked about move panels, it's time, according to our contents, to talk about deflection limits and backlining and lateral backlining factors. For that will also be found in property menu. So let's talk about the deflection. Here we can establish the limit and limit the deflection. In our case, we're just going to do it to demonstrate afterwards in the results. In this case, we're not placing any fragile object on top of any of these bars, so the deflection in this case might not be very important, but we're going to limit at least one distal bar of the frame to see some results when we come to the results video. In this case, the limiting deflection is available for absolute and relative values. Relative meaning in relation to the longitude, the length of the bar, and maximum absolute being the absolute value, and maximum and active. We can click here in this book icon to access the help to know that the maximum deflection is the maximum absolute deflection value, and that the active reflection is the difference between the maximum and minimum deflection. So here we can have a help of what is each one, and so we can know what we want to establish. In this case, we're going to limit the relative maximum deflection in the XZ plane, so this one, and we're going to limit it at the length divided by 300. Just remember when we go to the results that this is the bar that we limited the deflection for. And it's now time to speak about the backlining factors. Backlining and lateral backlining are both checked in the software, so we can establish the values by hand by clicking in backlining and selecting the bar. But there are two options to help us with this. As you can see, we haven't done any work on the backlink factors so far, and yet we have some backlink coefficients that differ from 1. That is because when we were exporting from Portal Frame Generator, remember that we selected that we want them to be in backlink in sway frames. So it has helped that with the bars that came from Portal Frame Generator. It's true that in this case, not many bars are going to be in danger of backlink, just the bars with compression forces, and that might be just the columns in this case. So no need to limit any other bar. But just note that the software CYPE-3D has also a more advanced tool to automatically or analyze the backlink, so we can then obtain the backlink factors. That would be a more advanced topic, and we're not going to cover it in this training, but please just know that the options to take it into consideration in the bars would be here: update the backlink coefficient in whichever plane and consider them in backlink analysis,